Hello everyone, my name is Neha. I am a student of BSc Chemistry Honours 6th semester. Today we will perform the experiment to separate and estimate iron using colorimeter. For this experiment, we have taken 6 standard flask and 2 beaker in which in one of the beaker ferric alum solution is taken and in another beaker, second beaker, we have taken blank solution, and these are 6 standard flask. In these standard flask we have taken 2% potassium thiocyanate solution, and in the next one we have taken 2% nitric acid solution. Here this is burette and this is burette stand with clamps. Now we will fill the burette with ferric alum solution up to the mark. Now we will fill first standard flask with 5 ml ferric alum solution from the burette. In the similar manner, we will fill the second standard flask with ferric alum, taking 10 ml of ferric alum solution from the burette. Similarly, in the third, fourth and fifth standard flask, we will transfer 15, 20 and 25 ml of ferric alum solution respectively. In this standard flask, we are taking 15 ml of ferric alum solution, and at the same point of time, we will see the mark in the burette so that the exact amount is transferred to the standard flask. Similarly, taking the next standard flask and transferring 25 ml of ferric solution in this one. Now we will fill the last one standard flask with 25 ml of ferric alum solution from the burette. Now we will add 2% of potassium thiocyanate solution in each standard flask by measuring it in a test tube. We will take 1/4 of test tube amount of 2% potassium thiocyanate in each standard flask. Now by measuring 1/4 of test tube of this 2% potassium thiocyanate solution, we will transfer it to the second standard flask. In the similar manner, we will transfer the same amount of potassium thiocyanate solution in the third, fourth, and fifth standard flask. Here, this chemical reaction shows the formation of ferric thiocyanate. Now, this complex can remain stable only if we add only in acidic medium. So, for this, we will add 1/4 of the test tube amount of 2% nitric acid in all the standard flasks so that the complex formed can remain stable. Now we will add distilled water to all the standard flasks and fill them up to the mark. Now, by using the cork, we will mix the solution thoroughly. We will repeat this thing with all the remaining standard flask. Here we have the unknown solution of which we have to find out the concentration. Now we will take the blank solution in the cuvette and clean it from the outer side properly using paper or any tissue. Now we will measure the absorbance and set the calorimeter at 0 at this particular wavelength. Now after calibrating the calorimeter, we will take our readings of all the 5 samples. First of all, we will take the sample 1 in which we have taken 5 ml of ferric alum. We will take this solution in the cuvette. Now we will clean this using paper and measure the absorbance by putting into the calorimeter. As we can note the value, now we will clean this cuvette using distilled water properly, and then only we will add the second solution from sample 2 in which we have taken 10 ml of ferric alum in this and again measure its absorbance by placing it in the calorimeter. Again we will clean it properly from the outer side. Now absorbance of sample 2 solution is measured. In the similar way, we will measure absorbance of sample 3, 4 and 5 and of the unknown solution. Then we will plot a graph between the concentration and the value of absorbance. Here by extrapolating the graph, as we know the value of absorbance of the unknown solution, we can find out the concentration through the graph, and hence we get the concentration of the given unknown solution of ferric alum and the concentration of iron in that using calorimeter. Here we have taken our final unknown solution and measure its absorbance.